Hello everyone, my name is Cesar Hita. I am an ophthalmologist, an oculoplastic specialist, and I also work in aesthetic medicine. Today, I am going to talk to you about botulinum toxin and its applications in aesthetic medicine. In the year 1820, when early explorers were reaching Antarctica and the Spanish Inquisition was officially coming to an end, a German doctor, Kerner, began to suspect that a toxin could be responsible for food poisoning in several German towns. In fact, in 1822, he postulated that there was a poison in sausage fat that probably produced this type of symptomatology, which is compatible with what we now know as botulism. Years later, Müller, another German doctor, named this toxin botulism because botulus in Latin means sausage. At the end of the 19th century, a Dutch microbiologist isolated Bacillus botulinus, as it was called then, without suspecting that it was the same bacteria responsible for the poisoning that the German Dr. Kerner had described in the past. It was in 1980, a century later, when an ophthalmologist, Scott, first described the use of the botulinum toxin for medical purposes, in this case, for the treatment of strabismus. In 1992, Carruthers published the first paper on the purely aesthetic use of botulinum toxin, in this case, for the treatment of wrinkles in the glabellar area. The first commercial toxin was commercialized under the name Botulinum. Scott marketed it, and the American laboratory Allergan quickly bought the rights and renamed it Botox. It was the first botulinum toxin approved for a variety of disorders, including facial spasms, blepharospasm. And it was also the first approved by the FDA for use in aesthetic medicine. Subsequently, because in Europe the toxin was obtained in another way, the Porton Company, based in England, manufactured a botulinum toxin for the treatment of cervical dystonia and named it Dysport. This company, Porton, was in turn bought by Ipsen, who became allies with Galderma, to produce the toxin we use now in aesthetic medicine, called Azelure. And lastly, Mons also began to market a toxin called Xeomin. It has some different characteristics from the previous two, due to a different production process from the previous ones. Its name for aesthetic medicine is Bocucha. When you read scientific texts, toxins are referred to as a toxin by their own name. Vistabel or Botox, which amounts to the same thing, they are referred to as botulinum A toxins. Azelure, it is ABO botulinum toxin A, and in the case of Bocucha, it is INCO botulinum toxin A. The difference between one and the other is the production method and the type of bacteria from which they are made. That is, in the case of Vistabel or Botox, the purification process makes the toxin, which is a double chain of 50 and 100 kilodaltons, be bound to two types of proteins, hemagglutinin and non-hemagglutinin, that give it a high molecular weight, around 900 kilodaltons, depending on the mechanism or the means of measurement. In the case of Azelure, its actual weight has never been published, but it is estimated to be around 500 kilodaltons. This will determine certain properties of this toxin, but this is not vital to make one better than another. When we talk about these toxins, keep in mind that they all come from Clostridium botulinum. It's a Bacillus flagella, anaerobic, has 4 different types of phenotypes. Each phenotype can produce several serotypes. There are about 7 serotypes that are differentiated by amino acids that make up the light chain. Botulinum toxin has a light chain of 50 kilodaltons and another 100 kilodaltons chain, linked by a disulfide bridge with covalent bonds. So our toxin, just like the coyote, aims to act on the neuromuscular junction. For the neuromuscular junction, the formation of a complex called SNARE is vital, which is basically made up of 3 proteins that, when fused, allow the synaptic vesicle to fuse with the plasma membrane of the axon and release acetylcholine into the presynaptic space for it to reach the muscarinic receptors. Therefore, the mechanism of botulinum toxin consists in the double chain sticking to synaptotagmins, which is a membrane protein. An endosome forms which, little by little, will acidify its content, so that disulfide bridge breaks, and in the light chain releases the cytosol of the presynaptic button. That light chain will fuse with SNAP25 protein of that SNARE complex, and will split it, that the SNARE complex will not form properly, and that pore will not be able to form. It will not be possible for the gallbladder to fuse with the membrane to release acetylcholine content, and therefore, we will get a flaccid paralysis of the muscle. This is very important, because this is the toxin's action mechanism. There are many myths around how long it takes, or the toxin, to do this. There are in vitro tests that have determined that the toxin takes at least 10 minutes to endocyte. So, it is a fast endocytosis. Therefore, many measures that we recommend for post-treatment would not be necessary. We'll talk about that now. It is also important to know that when we reconstitute the toxin, to be able to inject it in the face, or in an armpit or in someone's hands, it is better to use saline with preservative, with benzyl alcohol. All commercial brands give recommendations on how to reconstitute toxins, but they all recommend the same thing, which is to use saline without preservatives. But benzyl alcohol acts as a microanesthetic and improves tolerance to treatment, because the toxin hurts sometimes. As for how to reconstitute the toxin, each manufacturer will sell us the toxin in different units. Bocucha and Vistabel Botox, namely, ONA and Inco Botulinum Toxin A, come in vials of 50 units. Units refer to the quantity of the average amount of toxin that is injected in the peritoneum of mice to produce their death, so that 50% of them die. But no laboratory experiments, or uses, or measures their units with the same mice who are the same age, with the same buffer. So the units of one manufacturer are not comparable with those of another. But what can be said is that approximately for use in patients, the equivalence is more or less a ratio of 1:1 in the Inco and ONA units, Bocucha and Vistabel. However, with Azelur's units, ABO, botulinum A toxin, 125 Spayward units, are not at all like the units of the other two toxins, and therefore can lead us make mistakes. The clinical equivalence between them comes to around 2.5, or 2 units of ABO, versus one of the other two. So we can change when we use one or the other. It is probably simplest not to pay much attention to the manufacturer's recommendations. Galderma recommends to reconstitute Azelur with 0.63. The simplest thing is to reconstitute it with 1.25, as is done with the other two toxins. Thus we get equivalent doses with the same volume that we inject into the body. In other words, in 0.1 milliliters we are going to add 4 units of ONA and of INCO, and 10 units of ABO. They are more or less equivalent. It has not been shown that neither is better than the other. This is important. But it does seem that INCO has a little softer effect and lasts a little less. But there is nothing scientifically proven, because many of the studies are done by laboratories that have commercial interests, which is logical.